Okay, so today we're going to talk about gases and what you should know about them. So the first thing we talked about is gas properties. What should you know about them? So gases expand to fill their container. So gases like to spread out and fill the empty space. So things like burnt popcorn or someone spraying their perfume, you spray air freshener and it eventually gets around the room to it. They are easily compressed, which means you can put them in a tighter space. So think of something like an helium or an oxygen tank. And when it makes sense for them to make the tank the size of the balloons you're trying to fill, they get it as tight as possible, or things like gasoline, even that they liquefy, for that they can have lots of it in a small space, or other gases, and be able to fit more in the container and make it easier to ship it. They are less dense than solids and liquids, which means that they're more spread out. So when we look at that mass to volume ratio like we talked about first semester. Okay, so the particles in gas are moving very quickly. And this causes many collisions, so hitting against the wall. So think of popcorn popping or just throwing stuff against a wall in a closed container like a ball going back and forth. And when you hit something, that causes pressure. So remember, pressure means a force per area. So there's force when you push things against the wall, and the more times that happens, the more pressure this is. So we're going to draw these lines, and we're going to call these whooshies. I know, big scientific term here. And with something with low pressure, they wouldn't hit the wall very much here. Okay, so with lower pressure here, they don't hit the walls as much. With something with higher pressure, now we'll learn later that gases like to work in pairs. So something would have to have this happen to make this happen, like changing the pressure, changing the volume, that sort of thing. But more hitting the walls, more bending is how we're going to show the pressure in here. Okay, so we need to be able to convert pressure because there's different scales of pressure, and sometimes in a problem. Okay, so we're going to talk about pressure. Either ask you to directly convert it, or they're going to say it changes from one to another because certain formulas require certain pressures. So here's the ones you need to know. So 760 is a millimeter mercury or torr. 1.0 ATM, that stands for atmospheres, and that's the SDP. So you need to know these means SDP, but you don't have to memorize which is which or anything. 14.7 is PSI, pounds per square inch. Sometimes they use that in mechanics, engineering. 101.3 kilopascals, some people say pascals, either one's fine. And 101,300 pascals. So kPa, millimeters of mercury, ATM, those are the most common ones you're going to see. And you're going to need these to do a conversion, just like we did earlier the year with centimeters and inches and ounces and pounds. Okay, so we're going to use them as standards here so that you can convert. So the first thing you need to look up is their standard. So we want to go from millimeters of mercury to ATM. So that means I need to look these up, and at 760 is millimeters of mercury, and 1.0 is ATM. So the first thing I'm going to do here is decide whether I want to use proportions or whether I want to use my factor label here. So this would be if I like proportions. So I'm going to write down what I know, and I'm going to put it over X, and I want to label this with my units so I pick the right ones. I'm then just going to cross multiply. So first I would multiply these two, 525 times 1. So anytime it's ATM, you don't really have to put in the calculator. I'm then going to divide by the one that's with X, which is 760. So in my calculator, 525 divided by 760, I'm going to keep 3 sig figs, so 0.691 ATM. If I prefer to use my units, the dimensional analysis and factor label, I write down what I have. I write the unit I'm trying to get to, which is 1.0 ATM, over the standard for the unit that I'm trying to cancel out, so that's 760. Multiply on top, divide on bottom, so 525 times 1, don't really have to type that. Divide by 760, keep your three numbers, 0.691. Okay, so my next one, similar thing, but I've got different standards. So PA is 101,300 300 psi is 14.7. So here again is my proportion way. So 75,500 over x is 101,300 over 14.7. 75,500 times 14.7 over 101,300. Whoops, it should say PA. Fix that real quick. Okay, and then I'd take 75,500 PA times 14.7 over 101,300 PA. Either way, I get 11.0. So remember in these three numbers are significant. So that means I need 3. And since that would just say 11 in my calculator, I would need to round that off. I guess it did round a little bit anyways to 11.0. I can't just say 11 or that would have 2 sig figs. Okay, so the next thing we're going to do is a little bit easier, and that's temperature. And there is a scale called the Kelvin scale, and we have to use that because it has no negative number. So if I tried to type in a negative temperature or negative temperature, I could get a negative pressure and a negative volume if I didn't use the Kelvin scale. With absolute 0 being 0 Kelvin and no negative numbers, that's why we use this. So the number we need to know is 273. Sometimes you might see people using 273.15. I'm fine with 273, says the AP teacher. For Celsius, we're going to do Kelvin minus 273 if we want to go backwards. So it was already in Kelvin, and like sometimes the problem asks for what's the new temperature in Celsius. It's actually an extra step if they do it that way. So if I have 25, I'm going to add 273. It's now 298. If I want to work backwards and take 252 minus 273, that's going to be negative 21 Celsius for my temperature here. Okay, last little thing we need to work with sometimes is volume. And in most gas law problems, our volume needs to be in liters or L. So liters, 1,000 milliliters. So you can either set it up as a proportion or just know that 1,000 is 10 cubed. So we're going to move the decimal back 3 spaces left to get it in there. So for example, 575. I scoot that back 3 spots, and that would be 0.575. 2,450, move it back 3. Now remember that 0 is not significant. So that would just be 2.45. Now sometimes in a problem they'll ask you what is the new volume in milliliters. So say you solved and you got 0.263 liters. Then you would go and move it 3 to the right, only if it asked you for your volume in milliliters. Otherwise, there's no reason to really have to do this. Okay, so you need to get the worksheet if you were absent and practice doing these. So we got some temperature and some pressure conversions. One other special temperature that it asks about in this worksheet is absolute 0. So remember, absolute 0 is the coldest temperature possible. It is 0 Kelvin, and then figure out what that is in Celsius by subtracting 273.